I'd like to start this one with a puzzle. When we see what we think are current filaments in space, we see a magnetic field aligned with the current filament. Now, even in the double helix nebula, where you get this nice spiraling nebula, what the mainstream thinks is happening is the magnetic field is getting twisted. It's a magnetic torsion wave. But what we absolutely don't see is a magnetic field wrapped around it in one direction or the other. Now, if you are familiar with Donald Scott's model, you already know that we shouldn't be seeing a magnetic field consistently in one direction or the other, but that's only half of the problem. What are we seeing? And I'm going to direct your attention to one specific type of filament. When we have the sun's surface, we see these arcades, and we know that there's a magnetic field directed along that. That's the magnetic field that the mainstream says is going to stretch and finally snap and throw all the charged particles out. But let's look at what we're actually seeing if Donald Scott's model is right. First of all, the way we see magnetic fields, one of the ways, we'll talk about how Don's model is going to bugger up all of them, but one of them that we use is Faraday rotation. And what that depends on is three components, really. It depends on the strength of the magnetic field, the line of sight component of the magnetic field towards you, and the amount of electrons that are in the magnetic field. But here's where Don's model is going to really mess that up. If we look at one of Donald Scott's current filaments, remember it has a magnetic field that wraps one way and another radius it wraps the other way. So the problem is, when we look through one of his current filaments, we're going to see a line of sight component towards us, and then a line of sight away from us, and so on. And what happens in Faraday rotation is that cancels out. And by the way, pick another viewing angle. Let's look kind of down and into one of Donald Scott's current filaments, and you get the same problem, is that you're going to have, here's the axial component that's towards you and then away from you and towards you. So when you look down and into it, you're still going to get these canceling magnetic field lines. And what's more, in Don's model, since the magnetic field falls off so slowly, that means if this is again, we're looking through his filament with these reversing direction magnetic field lines, because the magnetic field falls off so slowly with radius, and because the magnetic field flips on such a regular basis, what that means is that we're going to get near perfect canceling of the magnetic field of the filament. We should never see in Faraday rotation one of Donald Scott's filaments. But here's what does show up. If you have one of Don's filaments flowing along a background magnetic field, even if that magnetic field is weak, simply because it's always in the same direction, that will show up in Faraday rotation. Whereas even if we have a strong reversing field direction, that cancels, and we'll see the background magnetic field. But this is the real kicker. What's one of the components we need to see that magnetic field? We need the electrons to make it pop. So what's going to happen is that even though the background magnetic field isn't any stronger in the filament than it is outside, since it's all the electrons in the filament that are going to make the field pop into view, what we're going to see is a stronger magnetic field here, and we're going to think that it's from the filament, but it's not. What's really happening is the filament with all those electrons in it is making the background magnetic field pop into our view. So what happens when this arcade expands, it's just highlighting the magnetic field that's there. It's not the magnetic field lines that are stretching. We're just seeing the obviously weaker field out here when that filament comes out there. It has nothing to do with the filament. The magnetic field of the filament, which keeps flipping in direction, disappears from our view, and we're only seeing the background magnetic field, which is getting weaker, but that means it's not individual magnetic field lines that are stretching after all. So that's really what's going on. That's why we see in Don's model, the magnetic field of the filament itself disappears from view in Faraday rotation anyhow, but a current filament should bring the background magnetic field into view just because of the charge density in the filament. Okay.